Hello, everyone, and welcome to today's Fireside Chat on emerging technologies and trends with DOE's National Laboratories. I hope everyone enjoyed our opening plenary this morning, and a special thanks to Undersecretary Menzies, Assistant Secretary Simmons, and Better Buildings Director Maria Vargas for making this all possible. I'm Alex Fitzsimmons, the Deputy Assistant Secretary for Energy Efficiency at the U.S. Department of Energy. And as the Deputy Assistant Secretary, I oversee a broad R&D portfolio focused on advancing the energy efficiency of America's homes and businesses and strengthening the energy competitiveness of America's commercial and manufacturing sectors, all of which are top priorities for the Trump administration. That competitiveness and our shared prosperity depend on science and innovation. At DOE, we are focused on advancing energy technologies that are affordable, reliable, resilient, and meet the needs of the end user, you, American business owners and consumers. And that's why we value our partnership with the DOE National Labs. Most people don't realize that DOE oversees a vast complex of 17 national labs that are the crown jewels of American research and innovation. DOE's partnership with the labs allows us to incubate and scale new technologies in a unique innovation ecosystem. And together, we are working to address the challenges that you all face every day to improve quality of life and technological innovation. So that's why I'm so excited about today's panel. Today, we're going to have a conversation with leaders from 3 of our national labs about the latest trends in the market and the future of new emerging technologies. This session was such a hit at last year's summit. We're doing it again. So no pressure on our distinguished panel. Like last year, for this session, we asked 3 leaders from different national labs to share with you the 1 or 2 things about. We asked them to focus on what they see as the real game changers that you and all the communities across the country might want to keep an eye out for. But before we get started, we need to go over a few perfunctory logistics. For this fireside chat, we will be using Slido, which for those of you like myself who didn't know, is an interactive platform for polling and Q&A. So if you're interested in participating, which we hope you are, please go to slido.com using your phone or by opening a new window in your internet browser. Not this window, which would close the session, but a new window. And once you get there, you'll see a place to enter an event code. And today's event code is #BBSummit, BB Summit. So once you enter this event code, please select today's session title in the drop-down menu, DOE Fireside Chat with the National Labs, Trends and Emerging Technologies. So I'll give everyone a few moments to open up Slido and select our session. You can see the information there. And while we're waiting, I'll point out that today's session will be recorded and archived on the Better Buildings Solutions Center, which, as Maria will tell you, has literally thousands of solutions. But we'll make sure you can find this one, and we'll follow up when today's recording and slides are made available. So right now, all of the attendees, and I assume there's a whole lot of you today, are in listen-only mode. If you experience any audio or visual issues anytime throughout today's session, don't ask me to help, as that will be an exercise in futility. But please send your message in the chat window located at the bottom of the Zoom panel, and one of our lovely and qualified technicians will sort it out. Okay. I'd like to ask our panelists any questions, and we hope you do to make my life easier. Please submit them anytime in Slido throughout the presentation. I promise we will get to your questions near the end of the session. So now that that's out of the way, and before we turn it over to our first speaker, we're going to launch a poll to get the conversation started. All right, so to help our speakers understand who is in our vast virtual audience and what interests you the most, please answer the following poll questions. First, what sector does your organization represent? And let's see, we're going to do this live in real time. So looks like right now, state and local government's in the lead. I'm not trying to handicap this horse race, but other is now in the lead, 160. You guys are good with the Slido. This is impressive. We already have 200 people who have responded. I wonder what the other is. But we have a lot of state and local government, manufacturing, industrial, higher education, K through 12, multifamily housing. It really reflects the diversity of sectors and viewpoints that comprise the Better Buildings Initiative, which is why it's such, why we're so proud of all the work that y'all have accomplished. Other is still way out in the lead. If you're an other or one of the others, and you want to let us know what sector you're in or how you would describe yourself, please feel free to do so in Slido. So we've got 266 and counting so far. You know, as you can see, panelists, a good mix of people across the Better Buildings portfolio. So, all right, so that's good. That helps us get a sense of who's out there so that we can tailor this session for you, because this session really is about you. So, question now, and we'll keep that going. So number 2, what new technologies would you like to see in your buildings in the next 5 years? And this is an open-ended question. And I'm not going to suggest anything because I don't want to bias you. But, all right, energy efficient, everything automated. Okay, all right. Some interesting cyber challenges there, but okay. Water reuse, solar and storage, zero energy ready, net zero energy. That's an interesting term. We have to define what that term actually means because it means a lot of things to different people. EV integration, 100% accurate metering, electrification, smart thermostats, zero energy design. There it is again. See, now that one's a little more specific. Design as opposed to zero energy. We are the Department of Energy, not zero energy, but it's an interesting conversation. Net zero water, sensors, electric everything. There's more. Automate everything, electric everything. A lot of interest in those technologies, and I have a feeling some of our national lab experts will be talking about a lot of this. And when I say I have a feeling, I mean because we did a dry run last week, so hopefully they got their talking points down. Clean energy, CHP, which for those of you who doesn't know is combined heat and power. AMO has a big CHP program. AMO is the Advanced Manufacturing Office in DOE. Bifacial solar cells, EV. Okay, so you get the point. Lots of responses. Thank you for participating, and you can continue to do so. And you know, I know we're going to cover a lot of these topics, so so thank you for participating in that part. Okay, so thanks for being good sports, and remember to submit your questions via Slido at any time during the session. So now let's really get started. And to start, we're going to have Judd Virden kick us off today. Judd Virden is the Associate Laboratory Director for the Energy and Environment Directorate at Pacific Northwest National Laboratory. Judd has been with PNNL since 1991, where he leads 1,000 scientists, engineers, and staff in developing solutions for the nation's complex energy and environmental challenges, which includes modernizing the power grid, advancing energy storage technologies, and increasing the energy efficiency of buildings and lighting. Judd earned his PhD and BS in chemical engineering from the University of Washington. Judd, take it away.
Alex, can you hear me?
Yes.
Awesome. I passed the first test. It is so good to be here. I'm excited to talk about some of the visions we have for the future. As Alex mentioned, I'm from Pacific Northwest National Lab. It's a national lab in Washington State. I've been there a long time. I love working at a national lab. But like many of you in the audience, we have about 4,700 employees, and we're right in the middle of transitioning them back to the 76 buildings that we have, 2.3 million square feet in 4 different locations across Washington and Oregon. So I feel the pain and the challenge that everybody has. Hey, I named my talk Healthier, Wealthier, and Wiser to hopefully grab your attention. But it really is going to focus on the combination and the convergence of a bunch of big things that are happening now and will in the future around energy efficiency, productivity, smart, connected, resilient, and I would even throw cyber secure in there. And the big thing that is really changing right now is we are all living through a digital revolution, and data is king. You're seeing wealth transfer to those companies that own and move data, and it's happening to us, and it's going to happen to buildings. And those of us who figure out how to best utilize the data that's going to be generated within our between communities and the electric grid are going to be the ones who make their buildings or campuses more efficient, more productive, more resilient. And the one that I'm really excited about, because it's going to be happening over the next decade, is going to be more healthier for those of us who live or work in a building. You know, our vision for the future, and that's what we're asked to talk about, is really a future building that has inexpensive sensors deployed throughout the building. Those sensors are connected with inexpensive automated control devices that will enable the building operator to optimize cost, comfort, health, and the productivity of those who work in the building. And this is the most important part of the digital revolution, we can do that all in real time. And that allows us to integrate and coordinate with renewable energy generation, whether it's distributed or centralized, on-site energy storage. I saw one of the comments in the poll was EVs. Yes, you could interconnect with EVs as well in the storage. It can interconnect with other buildings, communities, the electric grid, and by enabling all that to happen, it will improve the resiliency of the building, and if we do it right, will improve the resiliency of the electric grid. If I use my own campus as an example, we've been fortunate enough to have DOE funding that allows us to fully instrument 16 buildings on our campus. That's 10,000 sensor points that are all fully automated and controlled. They have diagnostic algorithms built in, and they're generating 14 million records a day for us to manage our campus. We're doing that with data that optimizes the efficiency to reduce our cost, reduce our demand charges, integrate our campus with energy storage technologies and distributed renewable energy, and making our grid more resilient, the local grid, and our campus resilient and cyber secure. And one key thing in this research world that I live in that is so important is we have lots of great research ideas that never make it out to practical applications. And ops people on our campus and their control center. These are the people who keep the lights on and the buildings hot and cool, and we've located them in the same building with our researchers to improve the odds of the new ideas actually making it out to our campus and then hopefully to the rest of the world. If we could go to the next slide. I've highlighted, I'm going to give you 3 examples and you can build that entire slide up. 3 examples where all of this is starting to come together. And the first one on the left-hand side is really all about lighting and the impact lighting has had. You know, today we have programmable and tunable solid-state lighting that allows us to save energy. But more importantly, maybe in the long run, it allows us to optimize lighting color and intensity to positively impact the environment we live in and we work in. We're doing research where we can tune solid state lighting to any lighting condition on the planet, and I'm talking about color and intensity. So imagine a future building where lighting, color, and intensity is automatically adjusted for each of us, or we can make it so it's more productive and healthier for us once we can have those correlations between lighting and health fully understood. And then maybe we each have our own customized lighting program, like we all have our own customized Starbucks order. But we're at the beginning of this. The scientific and medical community is just starting to understand the impact lighting has on our overall health. Circadian rhythms respond to light and darkness. Those circadian rhythms impact our physical and mental conditions. They influence our sleep-wake cycles, hormone release, eating habits, digestion, body temperature, and a lot of other things. And the study shown on the left-hand side of the screen is the first, one of the first scientific studies to measure light exposure and its effect on sleep and behavior in a care center residence. There was about 90 rooms in this facility. The team, and it was a broad team, were able to develop a methodology for collecting light exposure data and relating it to residents' circadian health. I think you can see there that big reductions in agitation and sleep disturbances just by tailoring and tuning the lights to have a better impact, on all the residents. What that made me think, I need to go spend a weekend there. And if I got to reduce my agitation and stress and improve my sleeping. So great progress there. The second picture, the one in the middle of the slide, is really an example of the power of machine learning and deep learning. The building shown there has 5 floors, 12 thermal zones. It has a very complex heating and ventilation and air conditioning system. Now, every building, as you all know out there, is unique. It requires its own custom model. These models, especially if they're physics-based, work really well, but they're limited by the challenge of obtaining an accurate controller. They need expert knowledge to set up, and they need a large amount of computational and dedicated software to run, and most of us just don't have it. So what the researchers did here is they used deep learning approximators, which basically is, you give these algorithms enough information, they'll train themselves to optimize the building, and you don't need all that computational horsepower or the expertise. And by doing this, it can drive down the costs of implementing and the maintenance cost of these new technologies. So not only can you get the 50% savings that you see there, we can also start to move this out to all kinds of buildings. Now, it's at the beginning. We're still at the, understanding how well this works, because the building operators have to have lots of confidence that it's going to work. But it's a really nice step to try to find a practical solution to apply machine learning and deep learning to buildings. And the final picture there on the right that says healthy buildings, this is one where a study of about 63 publications where they looked at air quality, and air quality was modified. Both indoor air quality and thermal comfort was improved, and it showed on average a 5.7% improvement in productivity and a reduction in absenteeism. So this is one that I think is kind of really at the cutting edge, and we'll be talking about it a lot more. And if you were at the plenary section earlier today, you heard a lot of discussion. But what we're really talking about is the ability to measure many aspects of a building, including air quality, thermal comfort, and then be able to correlate that to human performance. And just frankly, we don't have a lot of models out there that do that. We have a lot of models that correlate energy efficiency, but don't correlate the impact on human performance and health. And that leads me into my next slide, which is a model. It's being developed, it's called a Human Buildings Initiative Methodology. It's being developed by the Federal Energy Management Program, where it calculates the financial gain for a business owner for both energy efficiency and the benefit of improved indoor environmental quality. And remember, data is king. And what's outlined there on that slide is a methodology to take data, baseline that data, link it to human performance, link it to energy efficiency, and try to put a real number so the business owner can say, is it worth an investment to get there or not? We're doing 2 pilots at 2 of the buildings on our campus, where we measure carbon dioxide, temperature, humidity, lighting, daylighting conditions, and they're collected in the buildings. And then we evaluated recommissioning ventilation, the benefit of thermal comfort devices like window shading, whether it was worthwhile to have an envelope retrofit, LED lighting installations. And what we learned, it was the first cut, was at least in one building, over 10 years, we could save about $2 million. The other building wasn't as good, it was about $270,000. But now for the first time on our campus, and we hope others can eventually use this, and it's being used in 5 GSA buildings, you can start to put a number and a value on not only energy efficiency, but some of the other things that go along with it. And then that leads me into my next 2 slides and my final 2 slides, if we can transition to a really exciting that was just started by the Department of Energy. And this really ties back to Dr. Joe Allen's plenary talk this morning about healthy buildings need to be underpinned by scientific research. And we're fortunate that the Department of Energy has mobilized all its national labs to start to look at how we can take the broad scientific capabilities in our country and address some of the most important problems. And the Secretary of Energy and others have focused us on understanding the structure of the virus, modeling the spread of the disease, screening drugs, and then has started the initiation coordination of expanding some of the research. This here is an example of some of the expanded research that the team will take on. And there's the alphabet soup at the top of all the national labs. Those are all different labs around the country. But what we're really going to start doing is start to put a scientific underpinning about aerosol transport between rooms and the building HVAC system, so we can use our computational horsepower and our simulations and models and link theory to the experiments in the field, quantify risk and infection under different conditions, occupant density, humidity, outdoor air ventilation, airflow management between spaces, and then finally understand the transmission of the virus via materials and water systems. So I know this is something my staff ask about as they return to buildings, and I just can't wait till we build that scientific basis. We're all really excited to show that we can have impact on understanding that in the built energy environment. And that leads me to my final slide, which is how it all comes together, and you can go ahead and build that up. That is a laboratory that's at Lawrence Berkeley National Lab called their Flex Lab, where they're starting to look at some of these experiments. Although that might seem like National Lab employees sitting around the table, those are mannequins. But the point is, as this research community comes together, we are starting to build kind of the collective knowledge of what it will take to understand how pathogens move in the environment, how we control them, and you'll hear more about that from my colleagues on the panel, how we can normalize productivity, and then establish resiliency of all types within the buildings. And again, so excited to be here and look forward to your questions.
All right, thank you, Judd. Well, I've got a question from you that builds off of something that a couple questions that have come in on Slido. So, you know, as you mentioned, Judd, we heard this morning about making buildings the first line of defense relative to the spread of COVID. So how do you think the capabilities at DOE and the national labs, underpinned by scientific research, can best support helping buildings become that first line of defense? And specifically, can you comment on how ventilation and HVAC, considering indoor air quality issues, can help maintain healthier, safer, thermally comfortable indoor environments, particularly as we look to reopen schools and other buildings as the economy begins to recover from COVID?
Yeah, thanks, Alex, for that question. I really love the way it was phrased, buildings as the first line of defense. You know, and especially if take it, I love that phrase. The challenge is, and the plenary lecture talked about it, we don't have the scientific data and underpinning. And the good news, I think, is in the Department of Energy, which is very broad in its capabilities across all its national lab. We have the modeling, the simulation, our campuses are test beds. We understand and have deep expertise in biology. We have all the tools to put those together. And then if you look at the DOE programs across all of DOE, but I'll name out a couple, we have a very robust existing buildings program, both in the Buildings Technology Office, the application to federal spaces through the Federal Energy Management Program. So we've got the broad portfolio, we've got the broad set of capabilities at all the national labs, and we'll bring in universities, and we already work closely with industry. The challenge will be now to focus those capabilities down on the most important problems. In the last slide of my presentation, I forgot to show, maybe some of you noticed there's a picture of a truck on that slide. And the picture of the truck was meant to show that if something as simple as putting a skirt on the side of a truck, that's just an airflow challenge, increased the vehicle efficiency by 3 to 5% depending on the driving cycle. I was involved in that early. That took years of aerodynamic testing and modeling to come up with that, but it was a very simple and practical change. I hope we can do the same for buildings.
All right, Judd, a quick follow-up question from Slido. What's the timeline of the new DOE program to study COVID-19 transport indoors?
That it literally just got announced last week, and so it's starting ground zero.
What are you waiting for then?
Yeah, I know. It's no results yet. And, so yeah, hopefully in the next 6 months to a year, we'll start to see some good results and progress coming out. But it's got to be bigger than us. This has to be the entire scientific community working with our industry partners.
All right, well, thank you, Judd. And for those of you interested in asking Judd more questions, please keep them coming and we'll circle back at the end. But next we have Johnny Green, Associate Lab Director for the Mechanical and Thermal Engineering Sciences Directorate at the National Renewable Energy Laboratory, known affectionately as NREL. Johnny oversees NREL's transportation, buildings, wind, water, geothermal, advanced manufacturing, and concentrating solar power research programs. His directorate conducts R&D to enable technology innovation in energy efficiency, sustainable transportation, and renewable power. Johnny has a bachelor's in mechanical engineering from the University of Memphis and a master's and PhD in mechanical engineering from Georgia Tech. Johnny?
Alex, thank you for the nice introduction there. So Judd is always a tough act to follow, but I will do my best to try to complement the great information that Judd has shared with our audience. So thanks everyone for taking time out of your schedules to hear about some of the things that we're really excited about. And at NREL, one of the things that we're excited about is the transformation of our future energy system. And so one of the things that I'll be talking about is just some things that we're doing to prepare for the future energy system and some of the science and research, and also some of the things that we think are emerging trends that would be of interest to this community. So next slide, please. So as I mentioned, you know, we see the energy system will be transforming significantly. When we talked about some of the trends in the chat, we talked about electrical vehicle charging. We're probably going to have battery systems in homes. There will be solar on rooftops. We also see a future where there will be community renewable energy generation. There's just so many changes that are becoming, more communication devices, more smart devices in homes. So we just see this tremendously complex system, energy system that's coming online, where you really have to have, you know, optimization, coordination, control. You have to have a way to manage all the data that's coming in, and you have to not only have physical, like the ones that we develop in NREL for different systems at the individual building level, but you also have to have it in a systems complex. So we think there are three key pillars as we look out into the future energy landscape. So one topic is the connected communities that we'll talk about. We also see advanced building construction as a trend that's coming up that will be important. And also grid interactive efficient buildings, and in particular looking at how those buildings are integrating with renewables such as solar. So if you transition to the next slide, please. When we talk about connected communities, what we're really thinking about is, you know, if you have a existing development or a new development, and let's say if you want to have renewable generation on site, how do you, you know, do that in a way that extracts and provides the most amount of value for a subdivision or a community or a neighborhood? You know, for example, at a much larger scale, we're actually working with the city of Los Angeles right now to help them understand, you know, how much renewable generation could be produced for Los Angeles. And so we've modeled, you know, just thousands and thousands of buildings looking at, you know, electric vehicle charging and those kind of things. So that's on a city scale. We're also looking at things on a smaller community scale as well. So if we go to the next slide. So this is a project where we're actually working with the city of Fort Collins, and we're working with a local energy company, Holy Cross Energy and A.O. Smith and other partners, where we're looking at how to validate control systems for an intelligent, connected community in the Fort Collins area that's looking at high solar penetration. And there are other projects like this across the country, in Alabama and Georgia. Oak Ridge National Laboratory is looking at similar approaches. But what we're doing in this particular project is looking at how do you manage behind the meter resources and at the same time preserve homeowner privacy, and also looking at how do we coordinate homes in the community in a way that provides utility control. And so in this home energy management system within the individual homes, we're looking at thermostats and water heaters and PV systems, and then that data is being shared at almost in a cloud-like system where you can have community level aggregation of the data, and then you can make decisions that don't just optimize or benefit one individual home, but how does it optimize the energy use for an entire community. So by having these kind of controls inside of a building, sharing the data using some of the advancements in cloud computing, and Suresh will talk about how machine learning and artificial intelligence can do this in a little bit more detail in his next presentation. But how do you aggregate this data, use it in a way that provides a benefit for the community beyond the value you would get from an individual home? So next slide, please. So something else that we're really excited about is advanced building construction, and looking at ways where how can we manufacture buildings in a centralized way using advanced techniques that takes us beyond the very intensive labor out in the field, the way buildings are constructed right now. Buildings, we've been doing stick frame buildings for over 100 years, and so there hasn't been a lot of innovation in terms of building construction. So there is in addition to connected communities, another Department of Energy initiative is around advanced building construction. So in the next slide, we can talk a little bit more about what we've done at NREL. So one thing that we've done over the past few years is we partnered with a company on a prototype. They have this called an I-unit that's looking at how do you develop net zero multifamily construction. And so, typically when organizations are looking at advanced building construction or modular construction, they're really trying to improve quality with a repetitive manufacturing process, improve productivity, get cost savings, and they want to deliver, cost-effective homes. But one of the things that NREL is bringing to this is how do we bring energy efficiency to modular construction and advanced building construction? How do we provide the intelligence to have interactive buildings that can interact with the grid and share energy in the manner that I talked about previously? And also, how do you integrate renewables into these buildings? So we've got some recent activities where we're partnering with Oregon State University and several other organizations to look at how do we enable energy efficiency in advanced building construction. We really think this is the wave of the future, and we think, Judd mentioned COVID. One of the challenges earlier on was how do you quickly provide support services? So a approach like this with an advanced building construction approach with modular buildings is an approach that could have been used to quickly put up hospitals or other sites to address situations where you need to have a quick response or a quick construction in an unexpected situation arises. So not only can this be deployed for multifamily housing in traditional situations, but this also could be a way to rapidly construct buildings in emergency situations as well. And the third area that we're really excited about is grid interactive efficient buildings. And in particular, how do you integrate buildings with renewables? So in the next slide, we provide an example of a tool in the next slide that was developed at NREL called Foresee. And foresee is a home energy management system that actually received an R&D 100 award recently. And what this tool can help you do is really develop a cyber secure home battery system that can provide controls that deliver demand response, but also can help avoid homeowner impact. So Judd mentioned cyber security as an important feature. So, you know, having cyber smarts in your home energy management systems is critical. And so it's really designed for connecting your home appliances, rooftop solar. How does that communicate with the grid? If you have a home energy storage system, how do you manage all those pieces within your home? And then it's also looking at the future for electric vehicles. And how do you maybe even integrate other generation technologies as well? So we partnered with several industry partners, Southern Company, Eaton, Bosch, several of the partners on this home battery system that can really, once again, you know, help you optimize your renewable generation on site. How do you store that energy, and how do you optimize your energy use in a way that's beneficial for not only the homeowner to reduce their energy costs, but also in a way where the utilities can also potentially extract value from having this intelligent home system as well. So I think that is the last slide that I have, and thank you for taking time to listen about some of the things that we're excited about at NREL.
All right, thanks, Johnny. So I want to ask you about connected communities, since you brought it up and a number of people have asked about it on Slido. So help us understand why we can't just apply, you know, current best practices for building, operation, and design that were developed for single buildings. You know, why are connected communities and grid interactive buildings in particular an important R&D area? And you know, how would you see these technologies integrating, particularly into densely built urban areas, right? So that we can have these technologies can be adopted at a cost that's affordable for all.
So yeah, great question, Alex. Thanks for that. So just in terms of grid interactive efficient buildings, so typically, you know, when we've constructed buildings, they've been standalone. You know, grid interaction wasn't really even considered. It was, you know, how do you, you know, construct homes that use the least amount of energy? And so that was the traditional approach. But, you know, once again, the energy system is changing, right? We've got more renewable building, or at the community scale, or at the bulk grid level. And so we're looking at, you know, now we're at a point where the grid and the building have to interact. Maybe you have home vehicle charging, maybe you have a home battery system. So there's this energy exchange and transaction that's happening at the individual level. But if you have a connected community, then it can provide solutions and grid flexibility and reliability and efficiency at a much larger scale. And so we really have a huge amount of untapped potential to save energy across the country using this approach. So, you know, the main reason why it provides value is if you just have a building by building approach, you can't get those synergies that you could if you thought about energy use in a community in a more holistic level. So for example, let's say if you're going to build a brand new community, and let's say this community wants to have renewables integration, for example. So if you build a community the way you typically would without rooftop solar, and just build the homes, and then all the homeowners individually, you know, add it as they can, and develop it as they can, and they're not coordinated with the utility, you just won't get the same value as if, hey, we're building this subdivision, we're working with the utility partner, we're putting the PV in up front, we're getting a better cost because we're buying more in bulk, we're providing it up front, we've got the right incentives from the utility company up front. So now your homeowners can reduce their energy bills. They can potentially get revenue stream from grid services. And then the utility, they can defer or avert grid infrastructure costs because they know what they are up front. And they can also have increased reliability because they built it up front. So those are just some of the examples of the benefits that you get by thinking about it up front and building it in up front. And then also, Alex, you talked about, in an urban setting where you've got, this thinking about this up front. If you've got, let's say, once again, even if it's a modular construction in a urban setting with a bunch of units all stacked together, if they're connected, communicating and sharing information, that entire, multifamily urban building can save a lot more energy than if each unit is operating on its own. So it's really just using, data in a smart way to save energy, share energy, and provide better value for the American population.
All right, thank you, Johnny. Before we move on, I've got two quick fire questions, if you're game, from Slido.
Okay.
The first is, can the foresee tool be applied to schools or other commercial properties? Is it available open source? And the second is, I guess this is really three. The second is from Mary Fisher with Brandeis University. Our campus is considering increasing our reliance on electricity, geothermal systems, and deep energy retrofits. Does NREL have resources to help?
Okay, so I will try to answer the second question first, sorry. So we do have a geothermal research team that works closely with our building science team. And so we do have expertise in how do you integrate geothermal technologies in buildings. And that's also part of Alex's broad portfolio of looking at, integrating various renewable technologies with buildings. So yes, we could provide support there. And also in terms of foresee, I do believe that it could be applied to, buildings beyond just residential buildings. And I think it is a tool that can be accessed by, building owners and operators. So we can try and provide that information later if there's an interest.
All right, thank you, Johnny. So moving on, last but not least, our last speaker is Suresh Sunderrajan, Associate Lab Director for the Energy and Global Security Directorate at Argonne National Lab. Suresh leads a multidisciplinary team that applies expertise in science, engineering, and technology to solve problems related to energy, manufacturing, and global security. Prior to joining the lab in 2015, Suresh was Director of Innovation Business Development at United Technologies and has been on the founding teams for 4 different startups. Suresh has his PhD in chemical engineering from NC State and a master's in management and engineering from MIT. And if all that wasn't enough, he also holds over 30 US patents. Suresh, take it away.
Thank you for the kind introduction, Alex. I'd like to thank DOE and particularly Maria Vargas, Director of the Better Buildings Initiative, for this opportunity. Good afternoon, everyone. If I could get the next chart, please. When Maria reached out about this opportunity a couple of months back, she asked us to speak about developments at the lab about which we're most excited. At Argonne National Laboratory, I'm particularly excited about how new data streams and new materials have the potential for delivering significant gains in energy efficiency, increased comfort for occupants of buildings, and increased security and safety. Over the next few minutes, I'd like to build upon the presentations made by Judd and Johnny, but with a focus on specific innovations that complement the broader vision and programs that each of them spoke to. I guess it's the privilege and the challenge of going last after Judd and Johnny. I do want to add that the technologies that I will be speaking to are still in various stages of development, not quite commercially ready, but far enough along to have demonstrated proof of concept and allow some preliminary quantification of benefit. With that, if I could get the next chart, please. At the plenary session earlier today, Dr. Joe Allen spoke about healthy buildings. Judd talked about it a little bit in his presentation as well, and particularly the importance of indoor air quality. An important aspect of indoor air quality and energy efficiency is to understand leaks in the built environment. We estimate that about $30 billion a year is wasted from air leaks in buildings. If I can focus your attention on the panel on the extreme left of your screen, it's a description of an acoustic sensor technology recently developed at Argonne. This technology uses sound waves and advanced visualization to identify, locate, and quantify individual leaks in buildings. It can be used at any phase of construction and during any season. It can also be used in manufacturing settings, such as in pressure vessels, piping systems, etc. Sealing these found leaks can improve energy efficiency, and clearly also in the case of buildings, thermal comfort and indoor air quality. If I can move your attention to the panel in the middle, it shows a picture of a low-cost, easy-to-install electrical submeter that can be used in buildings, in manufacturing, and in industrial equipment. It was actually technology that was originally developed for our electric vehicle to grid connectivity program. The revenue grade rating speaks to the high precision and accuracy, as well as to the fact that the data is verifiable and traceable. To our knowledge, it's the first building meter ready for the proposed energy as a fuel changes being considered that will require meters of this sort to comply with the NIST weights and measures standards. And finally, shown in the panel on the right, as sensors become ubiquitous, as we start realizing the type of future that Judd spoke about, with sensors everywhere, communicating in a way that allows us to make granular and highly localized control decisions, we see a trend in developing and using printed sensors. Think of these as very low cost, low power devices that can be widely implemented. They incorporate passive and in some cases active technologies. They have wireless connectivity protocols built into the capability, built into them, and they're built on flexible substrates. So they can be conformable, they can be embedded, they can be placed in the environment as needed. Argonne is working with other labs in the complex, such as Oak Ridge and Sandia National Lab, on the roll-to-roll manufacturing of such sensors in a number of different applications. If I could get the next chart, please. I'd like to highlight a couple of interesting materials innovations. An estimated 30% of the energy that is used to heat and cool buildings is lost through inefficient windows. The panel on the extreme left describes the application of a thermochromic phase-change nanomaterial that is coated on a flexible, transparent substrate and is used as a smart window film. Thermochromic materials are materials that change color as a function of temperature. In this particular application, more specifically, they change their ability to absorb light. By tuning their composition and morphology, specifically of those of the nanoparticles, we can adjust their behavior in such a way so if they're coated on a window and say the external temperatures are above an ambient comfortable temperature, say 25 degrees centigrade, roughly 77 degrees Fahrenheit. Once the temperatures go above that they block incoming heat or solar radiation, infrared radiation. And as the temperature dips below 25 degrees centigrade, they allow heat in through the window. And all of this is possible without negatively impacting the visual light transmission. So it's a smart but passive switch to increase thermal comfort as well as offer significant energy savings. We estimate energy savings of the order of 18% from this application. Their center panel showcases work at Argonne on filter media made using electrospun nanofibers. We've been enhancing these fibers recently using antimicrobial and antiviral materials as we're looking to enhance the filter usable life as well as improve indoor air quality given the challenges that we're facing us today. This work is actually an extension, I should add, of work that we're doing in using very much the same technologies on building reusable N95 masks. I thought I would end by speaking to our life cycle assessment tools. As everyone in this audience knows, the Better Building Initiative's objectives are the challenge and the opportunity of energy efficiency. Life cycle assessment tools can provide information on embodied energy and emissions for buildings, for facilities, and for manufacturing. One such tool developed at Argonne is the GREET tool, Greenhouse Gases, Regulated Emissions, and Energy Use and Technologies. It's actually a suite of models or a toolkit, and originally developed for life cycle analyses in transportation, where it's become the gold standard with over 40,000 registered users worldwide. It is now being expanded for use in buildings. This tool is open source, and importantly, the data that underpins the models are both verifiable as well as updated on a regular basis. With that, I'd like to thank you for your attention and turn it back to Alex.
All right, thanks, Suresh. So you mentioned the GREET model right at the end there. I want to ask you a couple questions. First, you know, the GREET model seems interesting. I know we use it a lot within DOE, but for those who maybe aren't familiar with it, and other similar life cycle models specifically for building applications, I mean, why should someone use GREET? Why should someone care about that or versus other life cycle models or any life cycle model, right? Why does it matter to you?
Excellent question, Alex. To start off, life cycle analysis models allow us to model both the energy use, the embodied energy, the operating energy, as well as what happens to the materials and the energy, the greenhouse gas emissions and so forth over the life cycle or the duration from the initial mining process all the way through the end of life, if you will. That's what life cycle analysis tools do. And as we move to greater and greater energy efficiency in buildings, it's interesting to see the trade-off between embodied energy, the energy that is inherent in the process of building, and compared to, say, the operating energy use of in the operations of the building. As we think about sustainability broadly, it is important to understand how energy use, how energy is used, how emissions are created, and how one can trade off in terms of improving and optimizing, if you will, the construction and the operations of buildings of the future.
Okay.
There are many models available, both commercial, privately owned, software applications, as well as open source applications. The general challenges with all of these life cycle models is that the traceability of data, getting the the results, the scope of the assessments, and so forth. The value of GREET, if you will, is the fact that it is open source. The data is verified and traceable, and it does get regularly updated. So there are some benchmarks for consistency. I hope I've answered the question. Happy to take a follow-up as well.
All right, so here's a follow-up for you, Suresh, from Slido, particularly for you. Is the Sonic Building Envelope Evaluator available? Mr. Clifford has been working on this for the last 5 years, so he's very interested.
Great question. It has been demonstrated. The technology has been shown to work in commercial building settings, but it has not been commercialized yet. So it is not commercially available today. We'd be happy if the gentleman that asked the question would like to contact us. We'd be happy to connect you with the innovators and the team that has actually put together the demonstrations and talk about how we might be very interested in finding ways of commercializing this technology. We see a lot of value. We look forward to the inquiry.
All right. Well, thank you, Suresh. And please, everyone, keep the questions flowing. And we're going to move into the Q&A session. But you may have noticed on Slido, there's a feature that allows you to upvote questions that have been asked. So if there's some that you particularly like and would like to see, feel free to upvote them so they bubble to the surface. And we got a lot of time for questions now, which is really the best part about this, because this session is for you, right? Our partners. So we're going to transition over to the final piece of today's session, our live Q&A. So attendees, all of you, if you haven't already, you can go to slido.com to submit your questions. We have 70 already that have been posted. Enter the event code BB Summit and select the DOE Fireside Chat from the drop-down menu. Okay, so I'm going to start with one question to all of you to frame things up, and then we can go from there. So this first question is, what is the largest challenge, the single largest challenge you see in bringing the building-related technologies you discussed to the market, from the lab to the market, commercializing them? Who wants to start?
Judd, hey.
Oh, don't be shy now. Come on, Judd.
Judd, you always
All
go
right.
first, buddy.
I think for me, it's pretty clear, and it's been the same challenge we've always had, which is buildings are very disaggregated. You know, there's a lot of buildings, what is 85% or less than 50,000 square feet. And we can come up with all these really interesting solutions, but they have to be practical, they have to be inexpensive, and they have to be very easy to deploy to the market. They have to be very easy to install and operate and maintain. And we don't always put all those things together in an efficient way. And so it's, you know, there's been a lot of great examples where you could take a Raspberry Pi, you could put software codes on it, you can install it in a building, but you need someone to operate it and help it make the decisions that it's going to make for the building and then maintain it. And so that to me is the single biggest gap to getting new technologies out to buildings. And then it has to have the ROI. And in today's environment, it's even harder to have an ROI where maybe energy efficiency doesn't carry the same benefit. So that's why it's so important to put other benefits like productivity and health that put a value on it. And my view is Alex, we do it with a car. You know, and a couple of meetings ago, I said, you know, a car is the most expensive 20 square feet that we live in. You know, when you look at the amount of computational horsepower and climate control and airbags and everything else that goes with it. And we've got to get buildings to that same point so more things can be deployed and it can impact more people's lives.
Well, fortunately, most of us are not living in cars, but your point is well taken. All right, Johnny?
Not yet. Not
Well,
yet.
some of us spend more time in cars than you do in your where you live sometimes.
Yeah, that's true. That's true, particularly for our West Coast friends.
Yeah.
Right. Yes, yeah. Just to briefly add on to what Judd mentioned, I agree with what he said, and I think you know, the behavioral impacts and understanding what building owners and operators really need is important. So I think the more that we can understand, you know, what are the important value streams for that community and incorporate it into our research to reduce costs and functionality, I think that's important. And so forums like this are a great way to get that input.
And if I,
Suresh?
Yeah, absolutely. If I could add, well, I agree definitely with what Judd and Johnny said, and I'll quote an example from one of the cases that I talked about, and that is the acoustic sensor technology. You know, one of the interesting things about that sensor application is that it can be used for QA, QC, while a building is being constructed. So you don't need the complete envelope to have been fully built out in order to check, if you will, the structural integrity and the framing. So it has all of those capabilities. But interestingly enough, as we talked to you know, some of the construction folks or architects, et cetera, we realized that, you know, that is because there has been no technology available to do QA QC at that stage. It's not part of the regular process. So having this capability is actually a change in behavior. So to the point that Johnny made, some of these technologies require changes and practices that have been going on for decades, if not longer. So demonstrating the potential, and then if I could just add, and you know, kind of what Judd said at the beginning, but the part of the challenge with all of these technologies is that they have this valley of death that they have to cross. Just because you can demonstrate it in the lab doesn't mean that the value proposition, you know, crosses over when you do it at scale, and it doesn't accrue, if you will, as readily without a lot more investment. And therein lies the chicken and egg problem between making the investment to demonstrate the technology with some concern that the value proposition may not be there by the time you're done with the demonstration. And I think that that is also a significant challenge as you think about a lot of the, the technology applications in this space.
Okay, thank you, Suresh. And thank you all. So this, this next question has 15 upvotes. It is the most popular one submitted thus far, so I'll ask it. And I'll ask it to you, Johnny, since you specifically talked about connected communities, and this is somewhat related to it, but which renewable energy technologies may be best suited for low-income neighborhoods?
Oh, wow. That's an excellent question.
Based on maybe cost and availability, you know, a wide range of factors.
So I'll use the answer I use for most questions. It depends. So I really think if the right incentives and structures are in place, I think potentially solar could be viable for those community. And also, we had a question about, you know, geothermal resources. You know, those could be likely as well, but I think it really takes that cooperation between the utilities, the local community, the local government, those public-private partnerships. If those folks are working together and providing the right incentives and structures, those things can be done. So I mentioned that we were working with the city of Los Angeles to help them you know, understand what's a viable level of renewables penetration. And part of what we're looking at that is access to those kind of technologies for all communities. And so typically those communities are overlooked and solutions aren't structured for those communities. So we definitely have some work to do in that area, but I do think it's possible to do it if we have the right incentives and structures in place.
All right, now this question is now the new #1 question on Slido, and it is getting companies, workers, consumers to adopt new technologies is always a challenge. This is all the more so for advanced energy efficiency technologies, in this particular person's opinion, although since he is the director of the Building Technologies Office, he may be slightly biased. Thoughts on accelerating adoption of these advanced technologies?
Well, I'll weigh in on this one, and no matter what I say, I'm sure I'm going to be talking to David at some point about this. Well, my response is, I just don't see any other way to do it than engaging the stakeholders early in the process, so they understand kind of the readiness level of the technology. We have those kind of demonstrations that can show them and get them comfortable with the risk and the new technology. And this isn't a buildings thing. You see this everywhere. Look at deploying energy storage out on the grid or in buildings. There's a challenge of building that workforce up that is comfortable with that new technology. So once you get past the valley of death on a new technology, there still is a will it be accepted from a development, implementation, and deployment? And I think we can do a better job at training workforces, getting people comfortable with the technology earlier. And Alex, that's why we see, like at all of our campuses here, us deploying it ourselves. We've got people coming and visiting our campuses to see, tell me how it works. And honestly, they don't believe me. They go and talk to the facility and operations people, you know, who are the ones that if it's too cold, they get a phone call. If it's too hot, they get a phone call. So, you know, those are the people that really matter. Getting the people on the ground in the buildings who are responsible at the end of the day, plugged in early.
All right. Now, I love this next question, and it makes me glad to be the moderator and not a panelist. So this is from Jim Frey with Schneider Electric. What is your best example of proven tech that you know would be great, but you are amazed and or depressed that adoption is so poor? Don't make me call on one of you.
Suresh is had the tech transfer person. He's probably got
Throwing Suresh under the bus.
Yeah, I used to run the commercialization organization here at Argonne, so I can tell you that there are several examples of technologies that in the lab they look phenomenal, right? There's Argonne has a very rich history of innovating in materials. And, battery materials in particular, we have had a bit of success with. But we haven't stopped innovating in the battery material space. We have continued to explore new architectures for cathodes, of new morphologies, new compositions, for anodes, for electrolytes, et cetera. But the cost associated with actually commercializing these in terms of de-risking them, is a huge barrier. So while we can demonstrate very exciting potential at the lab scale, it becomes a huge challenge for us. So for me, particularly where I sit at Argonne, I will say that there are a number of storage technologies that build upon lithium-ion technology writ large, but looking at different electrolytes, different cathode compositions, et cetera, that all look very promising. And, really suffer from the, how much do you have to de-risk it before there is commercial, acceptance, if you will.
Okay. So it sounds like storage chemistries then.
Storage chemistries,
Suresh. Okay. Johnny?
And Alex, I think geothermal technology, we had a question about that. I think some of the, geothermal, heat pump technologies, have the potential to have more deployment. I think, getting some of the costs down with, drilling and some of the innovations in terms of foundation installations could help with that. So I think there has been some progress there that it would be great to see out in the market. And then also related to David's question about affordability that Judd answered, just to add on to that and build onto it, I do think grid interactive efficient buildings, even though they're not here today, that could also help with affordability by that, once again, that sharing energy information that can optimize communities and optimize the cost of renewables and new technologies.
All right. Judd?
Yeah, I would go back to one of the things I said earlier. It's about this digital revolution. There's just so many cheap, inexpensive ways to go measure your energy use on your campus. And if you're big enough, and like us, we pay millions of dollars, and we're in a part of the world where electricity is cheap.
Yeah.
Go instrument your buildings. It doesn't take much to interconnect. There's so many things you can do to maximize efficiency within that building. So for example, on your HVAC unit and on the rooftop, your rooftop unit, if we did studies for the Department of Energy across all the country, if it was just a variable speed motor that was interconnected to the temperatures throughout the building, and you had a good idea of your airflow, you can reduce the energy to that pump, that motor, by 50% on average, and your energy cost would go down 15% on the whole building. Mm-hmm. And then, as Johnny was saying, if you were interconnected to energy storage, or let's just use the grid, and you got a real-time price signal from the grid, our prices keep going up. Our energy use is flat, but our prices keep going up. Electrons move on two gradients, a voltage gradient and a dollar gradient. And if you can just become participating in that, and you've got enough
write that one down.
You got enough building space, you could save money. So I don't know why people don't want to save money. So.
Well, it begs an interesting question, though, which is, how do you make the business case for the adoption of new digital technologies, leveraging artificial intelligence and machine learning capabilities that all of you touched on? How do you make the business case? Because it's not always readily apparent, right?
We're in a workshop, but I think it has to be, you have to be big enough to aggregate enough building and energy use to make it viable. And then, there are all kinds of small software companies that are starting up and hardware companies with a lot of the new technologies that can put this together. And we kind of are at the front end of that. And I think it'll continue to take off over the next several years.
Okay. So here's another popular question from Slido, which is, how are you measuring occupant productivity, satisfaction, outcomes, parentheses, education, healthcare, retail sales, that link to increased investment in smarter buildings? So basically, how do we make sure that, like, what are we measuring when we say smarter buildings? What do we really mean by that? And how can we prove that we're actually increasing productivity, health of buildings, as you mentioned, Judd? What are some of the metrics so that we know what success looks like?
Yeah, the part of the story, there's a lot in there, and there's a lot of things you can start to measure. And the part of the story I didn't tell in that example I used about the 2 buildings at our facility, we're also able to go back to our HR department and kind of look at salaries, time worked, absenteeism, and then do surveys and polls and understand kind of the changing behaviors of our staff over time. You have to put all those things together. And so I don't think there's a generic paintbrush you can just put across it. You have to have the data for the people, your employees in your facility, and what is the value for them being there a little bit longer, or the productivity if they feel like their environment allows them to work at a higher, more productive rate. It is amazing to me, and we have to figure that out. And there's still more ways to figure it out. I'm told at my work, they know every keystroke and every key I hit on my computer and how productive I am. And you say the same thing in some of these other digital companies, when they look at your UPS driver. We can put those same kind of metrics around productivity. We just have to have all the right information sources.
Okay.
If I could build on that, Alex, I think I thought the plenary speaker earlier today, Dr. Joe Allen, did a really nice job of, I had never heard this metric before. I'm definitely going to look it up, but talked about, for $1 of, actual savings, or productivity improvement, how they were able to measure, 50 cents by, extrapolating, if you will, to understand what the benefit was in terms of value return to the organization or the company, in terms of worker health and productivity and so forth. So there was I'd never heard that metric before. I'm definitely going to look it up. But I thought that was really a telling way of looking at it, which is to expand the scope of value. So building on what Judd said, it's looking at it very differently. And if I could articulate that somewhat differently, it's a business model question. I mean, how do you define value and how to measure it is the question. And if you can expand that envelope to bring some of these interesting concepts in, I think we would be viewing the problem quite differently.
Hey, and Alex, if I could add one other thing to the original question, because there was a lot in there, but we have a solid state lighting lab that looks at kind of lighting environments that consumers, so if you're walking in a store, just really like. Now that we can change the color of the light and the intensity as human beings, there are certain wavelengths and intensities where we go, I just like that. I like the way the colors pop. And so I think eventually the good stores, and we've always probably, all of us have an example of a store they just like to go into. And mine is Home Depot. I can't explain why, but we all have a store that we like to go into. And I think there's going to be more science around lighting and other things that you might say, I like this. I like the lighting in this building. I like the way the apparel looks, the merchandise looks, and people stay in the store longer, or maybe they buy. That's going to be the power of data again, the power of collecting that information and using it to optimize.
Yeah, I don't think anyone's ever been accused of liking the Forrestal building. For those of you who have been by, that's why that's why we like getting out into the field and seeing what's going on at the labs with all of you, which is great. So a lot of you are interested in electric submeters because it is now the most popular question with 22 upvotes. So I'll ask it. There was a discussion of low-cost electric submeters. Are they commercially available? This person is always looking for affordable submeters to measure tenant spaces in multi-tenant buildings. Who wants to comment on that?
I'm happy to take that first, Alex, because I spoke to the technology that they're prototyping and developing here at Argonne. And as I mentioned earlier, it builds off of electric vehicle submeters that we were developing for vehicle to grid interconnectivity studies. And it is pre-commercial. Everything that I spoke about is kind of at various stages of development, but it is, I will say, at a TRL3, TRL4 level. There are active discussions going on right now in working groups. I believe that standard setting bodies about what the specifications should be around that particular meter and the requirements associated with that. But this particular demonstration that we have done really is my understanding of what is possible. Again, because I spoke about pre-commercial technologies, if there is interest, I'm very happy to connect with folks afterwards and put them directly in touch with our PIs. We are anxious, to David's earlier questions, how do we accelerate adoption? Perhaps it's through forums like this, where we can tell you about the cool stuff we're doing. And if you like it, that gives us a direct line, if you will, to the market.
Alex,
all right. Yeah, go ahead, Johnny.
Yeah, just to add briefly what Suresh mentioned, in addition to what Suresh mentioned, I also think there's an opportunity to use artificial intelligence and machine learning, as almost surrogate sensing technologies. So it's probably going to be, some combination of the two. But I think as we continue to have advancements in that space, I think that will be there as well. And then also modular buildings can also allow for some new approaches for sub-metering as well. So those are just a couple of additional thoughts to build on what Suresh mentioned.
Okay, so I think I'm going to change gears a little bit here. All of you have mentioned artificial intelligence and machine learning. So as we start to see more applications of AI and ML applied to buildings and the energy system, what do you see as the key challenges to ensure that that these technologies can be deployed across multiple types of buildings to achieve, energy efficiency, resiliency, a healthy environment? How can we make it practical and deployable?
Well, I guess I can jump in first. I think there are a couple of things. One is cybersecurity. Judd mentioned that earlier in his presentation. So I think being able to have secure data is important. And then something else, this is a little bit more in the social sciences and behavioral science, but data privacy. Folks feeling comfortable that the data that's being collected will not be shared in a way that they're not comfortable with. And so I know in particular with the Building Technologies Office, they've really emphasized in any research that we're doing that, data privacy is a really important element of it. And so those are a couple of thoughts that come to mind.
Well, so let me ask you a follow-up question there too, because E equals MC squared is asking, I know that many people are intimidated with smart devices due to privacy concerns. Is this taken into account when we're considering what metrics we'll use in our homes as we're creating these new technologies?
I think we have to. Sometimes these things are considered, quite often they're normally thought about on the back end, but I think if we can think about them more on the front end, we'll be much further ahead. And I think the worst thing that could happen would be to have a great technology that's developed and then gets deployed and is exploited in a way that does harm to the consumer.
Yeah, and I'll just chime in. In our own home, I guess it's our own choice. We get to make that choice on how concerned we are about privacy. In the workplace, there's real issues. about how you use data, and that has to be worked through, and there's no easy way around that. I will say to the original question, I think on the machine learning, and one of the big things, I agree with all the other comments, is interoperability between different systems. So you want to be able to take anybody's sensor if it's and link it to a controller, apply a data analytics, whatever variation you might want to, and then be able to send signals out to devices that actually control energy use. So that interoperability I think will be important going forward.
And a related issue to the adoption of new digital technologies using AI and ML, of course, is cybersecurity, as a number of you mentioned, particularly with interconnected, interoperable devices and technologies. So we know that these are increasing both within buildings and the grid. So how do we make sure cyber is part of the future discussion and that we are developing new technologies that are cyber secure from the start versus trying to patch it on later?
Yeah, I know Johnny and Suresh will want to chime in here. We do a lot of work in this area, both on the grid side and on the technology side, and it's a real concern, and it's something we all need to pay attention to. And it's I think it's very hard to test every single device that's going out there. So I think one of the common approaches that's been being used is industry best standards from the beginning, both at the device level and the system level. And that goes down to kind of security codes, validation of those security codes, integrity of the devices, and that will be all of us. That will be the industry partners, the vendor supply chain, building that into these. Literally, I think it's billions of devices that may be connecting to all of us at the edge. So it's about cyber best practices built up through the industry, with some checks and validation that they're working.
Yeah, I also think by combining physical assets and virtual assets to evaluate scenarios that Judd talked about, there's so many. I think that's a tool that we can use to help evaluate the hardness and security of some of these new integrated systems approaches and solutions that are being assessed right now.
Yeah, I have to agree. I think that, starting with the design and incorporating, cyber best practices right from the design stage and in the standards process, having, if you will, the communications early and keeping this as a key issue through the process is what it's going to take. I can give one example from the LED lighting space where, I think that, in the early days of LED lighting, I don't know if you remember back in the 2006, 2007, you could go to the store and buy LED lighting and, what you got was very unsatisfying. In terms of a product quality and attributes and light and so forth, very different from what I think, and I give DOE a lot of credit for this, is being able to bring industry and the labs, particularly PNNL, in helping set, if you will, protocols in place where there were, unbiased testing of all these products, and then the data was just put out for industry to then react to and decide what they wanted to, put on their shelf. And that changed by 2012, 2013. The quality of the products that you could get at any of these retailers was far superior, and you had some, shall I say, some confidence that what you bought would meet the expectations or what it was being sold as. And I think it's exactly the same kind of effort that I would encourage that we all look at to make sure that the devices that we are buying meet the standards and incorporate privacy concern, the right kind of regulations and processes for privacy, cybersecurity, et cetera.
All right. Well, thank you all. I think that's going to be all the time we have for questions. We had literally exactly 100 questions come in. So We tried to get to as many as possible. Thank you for submitting all of those questions, making my life tremendously easier, making their life a little bit tougher with some good questions. But I know they're all happy to answer them, because this is what we're here to do. You know, we're here to serve you, our partners. We're here to be a resource for you. And DOE and the national labs work in concert together, hand in glove, to advance all of these technologies. And so you can always reach out to us, and we'll have our contact information at the end to answer the questions that we couldn't get to. But before we close, I'd like to play a quick video showcasing our Better Buildings Solution Center. The center has over 2,800 solutions to help achieve your energy and water goals. So let's check out this shameless plug video to learn more. Well, there you have it, very dramatic music. So if you're interested, please check out the Solution Center if you have not already, or Maria Vargas will track you down and make you do it. So as a final housekeeping note, we'd also like to invite you to attend our Better Buildings Summer Webinar Series. Starting in July next month, partners will discuss some of the most pressing topics you're facing and share innovative new ways to approach sustainability and energy performance. To register, go to the Better Buildings Solutions Center right there and click on the 2019-2020 webinar series. And so with that, I'd like to thank our panelists very much for taking the time to be with us today. If you'd like to learn more about the resources discussed today, you already know what I'm going to say, but to belabor the point further, please visit the Better Buildings Solutions Center, or feel free to contact me or Maria at the email shown below. So thank you all for being here today, and thanks for all the work you do to help make this country productive and prosperous for all. Thank you.